We are learning about right triangle trigonometry today. I know I've got this when I can use the lengths of sides of a right triangle to find trigonometric ratios, use trigonometric ratios to find missing parts of right triangles, and use trigonometric ratios to solve applied problems. So some of the key vocabulary: trigonometry, side opposite, side adjacent, hypotenuse, sine, cosine, tangent, angle of elevation, and angle of depression. So you can go ahead and look at this. What I want you to see is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You definitely need to write this down. Down at the bottom, I have SOHCAHTOA. So it's sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Example 1A says find the sine, cosine, and tangent of A in the triangle. So I have this listed for you, but all you would have normally would just be the triangle, okay? So we are trying to find all of the sides. To do that, your very first thing that you're gonna have to do is you're gonna have to use the Pythagorean first to find C, okay? So what you have to do is you're going to use the Pythagorean theorem to find C. So this is the very first thing that you have to do. So we're going to go a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. And then we end up solving that and getting c equals 13. Okay, so c equals 13. So now sine A is opposite over hypotenuse. So what that means is the opposite side from that angle is 5, and then hypotenuse is 13. Cosine means adjacent to that angle. Adjacent means next to. So if this is the hypotenuse, we know because it's across from the right angle. This is opposite because it's across from it. Then this has to be the adjacent side or the one next to it. Okay, so adjacent is 12 over the hypotenuse, which we said was 13. And then the tangent is opposite over adjacent, so 5 over 12. So you really have to know those ratios. 1, B, and C. So I'll do the first one, or we can do it together, and then y'all are going to do the second one. All right, so using the given right triangle, find the ratios for sine, cosine, and tangent. Okay, so we have to find, for A. All right, so we have to find what this missing side is first. Okay, so we have a squared plus b squared equals c squared. I know two of my sides are 5 and 12, but I don't know my hypotenuse. So if I do that, I'm going to end up getting that c squared is 169, so that would mean that c is 13. Okay, so what that tells me is that sine of A is opposite. So sine A is opposite over hypotenuse. Cosine A is adjacent over hypotenuse. And tangent A is opposite over adjacent. And you try the second one. All right, and this is what you should have gotten. All right, number 2, it says find A and the right triangle shown. So what we have to do, we're looking for A, we have this angle and we have this side, okay? We need this side. So from this angle, this would be the opposite side, and this would be the adjacent side. So you have to think which trig function gives you opposite over adjacent, and yes, that is tangent. So tangent of the angle equals opposite over adjacent. So tangent of the angle gives you opposite over adjacent. So that is, I'm basically filling in this formula. Okay, now I just find A. So I would isolate that, multiply both sides by 120, and when you do that in your calculator, you get 84.02. So you're going to say it equals about 84 centimeters. So the biggest part is setting up the first ratio. Okay. This one, now we're going to find C. So we have this angle again. We have this side, and now we're looking for this one. So from this angle, this is adjacent, and this is hypotenuse. So which trig function says adjacent over hypotenuse? Cosine. So cosine equals adjacent over hypotenuse. So we're going to say cosine of 35 equals the adjacent side over the hypotenuse. Now we're going to isolate C, so we're going to multiply the denominator by both, and then you would have to divide by cosine of 35 to isolate the C. So you end up getting C equals 120 over the cosine of 35. And when you put that in your calculator, you will get C equals about 146.49. So you can say about 146 centimeters. You try one or two. And you should have gotten 8 feet and 13 centimeters. Okay, go ahead and try these. And the answers are down at the bottom. Okay, an angle formed by a horizontal line of sight to an object that is above the horizontal line is called the angle of elevation. That's right here. The angle formed by the horizontal line and the line of the sight to the object that is below is called the angle of depression. So in number 3A, it says from the point on a ground level, from the point on ground level, 125 feet from the base of the tower, the angle of elevation to the top of the tower is 57.2 degrees. Approximate the height of the tower to the nearest foot. So we have this picture, okay? So it says the angle of elevation, so you're on the ground looking up, is 57.2. We want to find this, okay? So from this angle, this would be the opposite side, and this would be the adjacent side. So which trig function deals with opposite and adjacent? Tangent. So tangent of 57.2 equals opposite over adjacent. So to solve for A, you multiply 125 by tangent of 57.2, and you should get that it is about 194 feet. (3B) says a building that is 21 meters long casts a shadow 25 meters long. Find the elevation of the sun. So they are wanting this, and they are giving you this side, which is opposite, and down at the bottom is adjacent. So you think tangent of A equals opposite over adjacent. But if they're giving you the sides, how do you find the angle? In your calculator, you have to hit second tangent, and it'll look like this. And then, hang on, second tangent, 21 over 25, and that will give you A. And when you do that, you should get, let's see, 40 degrees. It's about 40 degrees. (3B). A helicopter hovers 750 feet above a small island. The angle of depression from the helicopter to the landing pad is 15 degrees. How far to the nearest foot is a small island from a landing pad? So this is what I came up with, okay? So the helicopter is 750 feet above the island. The angle of depression is right here. That's 15 degrees. How far to the nearest foot is the small landing pad from the island? So we're looking for this X right here. We're looking for this. Now, if this angle of depression is 15 degrees, then I know this has to be 75 because 90 minus 15 is 75. And I know this is a right angle. Okay. So how do I find that? Well, from this angle, this is the opposite side, and this is the adjacent side. So I say tangent of 75 equals opposite over adjacent. So to solve, I multiply both sides by 750 in my calculator, and I get 2799 equals X. So I know that that means it is 2,799 feet to the nearest landing pad. Okay, so you try this one. All right, when you did that, you should have gotten the angle of elevation is about 54 degrees. Okay, here's an extra challenge to find the length of X to the nearest whole number. I'm going to tell you the answer, and then I want you to figure out how I did it. So the answer is 50 inches. All right, what I did first is I found this length first. Okay, so I said tangent of 70 equals opposite over adjacent. When I did that, I got that y equals 54.59. Then I said, okay, tangent of 55 equals 150 over z. So I labeled this whole thing across z. When I did that, I got that z equals 105. Well, I knew the length of the whole thing. Let's see, hang on, x plus y, so equals the whole distance. So this x plus this y equals the whole distance, right? And I'm looking for x. So I knew that if y equals 54.59 and the whole thing is 105, I just subtract. And when I do, I get 50 rounded to the nearest thing. It's really 50.4, but they said to the nearest whole number. So when you do it, you get 50.4, but they want you to round it to the nearest whole number. So X is 50 inches. All right, I know I've got this one. I can use the lengths of the sides of a right triangle to find trigonometric ratios, use trigonometric ratios to find missing parts of right triangles, and use trigonometric ratios to solve applied problems. So what are the 6 trig ratios and what do they represent in context of the right triangle? So there's actually 6, but we only need to know about 3 right now. They represent the ratios of the sides of a right triangle. If A is an acute angle of a right triangle, then sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Suppose one angle of a right triangle measures 40 and the hypotenuse of the triangle measures 10. What equation could you use to find the length of the leg that is adjacent to the 40-degree angle? Cosine 40 equals x over 10 because cosine is adjacent over hypotenuse.